Hey everybody, today I just want to do a quick video on code reviews. This is something I think a lot of companies don't do, and a lot of, and kind of regardless of size, right? Like big or small. I think obviously the bigger the companies, you get a lot more of this, but a lot of the smaller companies, you have a lot of people that are individuals that are specialized at something, and they might be the only person who's familiar with something, or even programming, right? And so because people are kind of more isolated, we tend not to do code reviews. And yeah, everyone's busy, right? So sometimes we argue, right? We just don't have time for this. So I wanted to talk a little bit about what code reviews are, why they're a good thing, and then how to be effective as we do these. So first off, I just want to talk about the benefits of code reviews. So first one, we get increased team morale, right? So I'm developing code for a project, and this again is totally non-specific to LabVIEW, right? This could be any programming language. But yeah, it increases team morale. We get people in the team looking at what other people are doing, collaborating together on solutions and improvements and things like that. So overall, increase team morale, create a culture of innovation and collaboration. So again, just bringing people together to talk about things instead of doing so much in isolation. It improves code quality, so we can find different things. We can find bugs. We can find things that may not scale well. We can find just poor kind of coding practices, right? Improvements that can be done there. All sorts of things. We can reduce the risk of the application becoming unsupported due to a key person or persons leaving. So, there's a lot of those, especially in that small to medium sized business, right? Where you've got like a single individual who builds some software system, and they're the expert at it, and then they leave, and then no one knows anything about it. They're not familiar with the language. They're not, maybe at a skill level that can support it, and it just creates chaos, right? So then you're looking at, well, how can we either train people up, or do we need to hire like a contractor who can help us, maintain this, etc. So, bringing people together, you've got all these different people that have eyes on the code. So even if they may not be the experts at the code itself, they've walked through it before and they know more or less how it works. So it does help reduce that risk. Obviously, the person that wrote it is going to know it far better than anyone else, but it does help kind of build that cross training and collaboration there. It also increases compliance with team style guidelines and reuse libraries. So, yeah, it just helps everyone in the company work in a more consistent fashion. That way, you don't look at, even in the same language, right? You could have people that write code that do it in an incredibly different way, and it looks entirely different. So just helps kind of enforce some of those style guidelines so code is consistent across the facility. You spot opportunities for reuse. So yeah, if you're reviewing code, right, and you're like, hey, it seems like everybody is always writing code that does error logging or something like that. Well, maybe we can come up with a good generic error logger that everyone can use in all their projects, so we don't have to keep reinventing the wheel. So stuff like that. It also helps bring new team members up to speed on team coding practices. So, you have some new developer. Well, they may know how to, develop code already, but they may not be attuned to your company's specific practices and procedures. So, by doing this, they're part of that code review process, and they learn very quickly what are the do's and don'ts, and what is being looked for in that. So yeah, let's talk about some tips, right? And this kind of diagram just kind of shows the general workflow, right? So you've got like a developer who is developing code on their machine, and they're testing their code on their machine. And then, once they're happy with their code, then there's a code review, right? So we're, connecting with these people and, going through it, looking at, is there any issues? Is it meeting our company guidelines, stuff like that? And this can be iterative, right? Hence the arrow. So, right, the code review can lead you back to changing things. if there's things that need to be changed. And so this could be an iterative process. Once we're happy in the code review, then we can go check in the code to our repository. So that's the general workflow. Obviously, your company can change that however you see fit. So yeah, just a few tips. As the reviewer, take the time to understand the details of the problem the code is trying to solve. So yeah, don't just look at the code as the code, right? Like, we need to understand, well, there's some reason why this code is necessary. Right, there's a business incentive. It's not just no one's just writing code to write code, right? So there's some business reason why we need this. So understand what is actually needed, not just looking at the code and what it does. And that's going to help you actually evaluate the code much better, because you're looking at it from the business perspective and less at the code itself. So use automated tools for anything with definitive yes or no answers. So you can dissect code in a peer review line by line and looking at every single little thing. There's a lot of things that you don't need to do that for, though. There's tons of different tools that can scan your code and basically check for certain things, or even fix those things, right? So there's a lot of formatters out there that can run through your code and fix things, so you don't even need to check for those things. So just some examples. VI Analyzer is really good. You can run all sorts of tests, and you can create your own custom configurations based off of your company guidelines. So that way you can basically just run VI Analyzer on a project, and based off of your configuration, it's going to check your code for certain things. So you can configure it however you want, really. And that will basically give you like a yes, no. Like, does this VI meet this standard, yes or no? And you immediately have that feedback without having to go read through all the code. Same thing for security issues. There's lots of stuff out there. I've made a lot of custom VI Analyzer tests for specific security issues. I made a previous video on those if you want to check them out. If we're looking for potential of like an OS injection, or like a SQL injection, or unsecure, non-encrypted network communication protocols and stuff like that. So if you're interested in those, there's those. A lot of other programming languages, not LabVIEW specifically, have really good SOS tools, so like your static application security testing, that find those things. LabVIEW, VI Analyzer is great, but it's not specifically set up to be like a SOS tool. So it takes some custom, working with to get it working correctly for SOS, but it can be done. I have some of the tests there. Obviously, you can take that much further as you look for things like security issues, vulnerabilities, stuff like that. So another really cool tool out there is Sam Taggart has his Blue Formatter. It does a really good job at, you can basically just select a project, and it will go and it will reformat things in your code. So, and he basically has kind of a default set of things that it does. And I mean, I haven't ever tried to kind of augment that, but to my knowledge, I think you're able to go in and basically augment it and change all of the things that it can do. But yeah, so like, for example, removing compiled code from VIs, right? Well, you could manually in a peer review go check each VI that it doesn't have compiled code, or you can just run a formatter that goes and does it all, right? So that way you don't even have to check those things, because you've run the formatter. So if it was already compliant, the formatter just does nothing. But if it wasn't, the formatter actually fixes it. So there's really good tools for that. The more of those you can use, the less that you have to really dive in on a lot of those things in a code review. Use bookmarks to make comments in VIs, so it makes it easy to reopen. So if you never use bookmarks in LabVIEW, they are fantastic. So I'm just going to open a simple project and kind of demo this. So we have this kind of demo factory. So a bookmark is basically a way you can take a free label and bookmark it. So what you're going to want to do is anywhere in that bookmark, if you do kind of the pound or hashtag or whatever, and then add like any word to that, right? And it's going to bookmark it with that word. So so I could add like, hey, check this, and then I can add space, and I can add some sort of note, right? So the bookmark is going to be check this, but then I can add comments about what specifically could be optimized. And I can also even go, point and arrow to what thing could be optimized, right? So you can do stuff like that. And I can add these all throughout a project anywhere I want. And then if you just go to view and go to bookmark manager, it's actually going to break down all of your bookmarks, and it actually categorizes them by the bookmark kind of hashtag itself. But you actually can click on these and it takes you right to the bookmark as well, which is really cool. So if you're reviewing someone else's code, this is an awesome way to leave notes all throughout the project that someone else can just open this up and they can just navigate through. And you can kind of categorize things by the text you use here. So if I say, hey, you absolutely need to fix this, I found a bug, stuff like that, versus maybe optional stuff, right? You can kind of distinguish those things. Like you could have like a hashtag security, right? And highlight this is a security issue. You can have like a hashtag bug, or you can have like a, hey, hashtag, optimize, or, stuff like that. So you can actually create all these different categories. I think it's best if your organization standardizes on some stuff, but this is an awesome tool for those peer reviews to keep things organized and making sense. So that would be one piece of advice. And then use code review for more subjective topics such as, is this the best architecture and what could be done to improve memory usage? Don't get too particular on all of the code. No one wants someone who's really going into every little detail of the code and nitpicking everything. No code is perfect out there. Obviously, right, the goal is we want to make sure the code complies to our company guidelines, it works, and it's secure, right? Those are the biggest concerns. So focus on things like, right, is this architecture going to scale well with this system? Memory usage. Oh yeah, well I noticed it's kind of high, right? What can we maybe do to help optimize that? Also have some reviewer tips. So code review is a collaboration and opportunity to learn, not a point scoring exercise. So right, the goal is everyone is learning from everyone in those experiences. We've got the reviewer and the reviewee, right? We're all learning together. We're looking at the code. We're all able to collaborate, share experience and knowledge, and make sure that the code meets the requirements our company has for it. So we want to also build a set of prerequisites to a code review. This just makes code review way easier, right? So if there's a lot of just obvious yes, no, like I was talking about, run VI Analyzer and just have a report from VI Analyzer already ready that someone can just look at and say, oh yeah, this project passed all of these like coding style tests. It's good, right? Have unit tests on your code, right? So I can look at the unit tests and I can say, oh yeah, it looks like, this function does work. Oh, I see, you didn't test for this possible weird edge case. So there might actually be a bug in this. Let me check that, right? So unit tests and static analysis tests, anything you can generate kind of as a prerequisite, just makes peer reviewing so much easier because I don't need to consider everything in your code. There's already a lot of documentation that's been done automatically where I can just look at it and say, oh yeah, this is good. Except that everyone will have small differences in coding style. So as long as the code conforms to the team style guide, accept it, right? Everyone's going to do things differently. There's not, especially in coding, there's a million ways to do anything. There's not always a right or wrong. And sometimes, right, there might be a better way to do it, but let's say it gives you a 1% boost in performance. Well, that might actually not matter at all, right? So is it really worth the time to hash that out? Not really. Again, this is why you want company guidelines, so that's what you're judging off of and not personal preference. And again, raising every little problem is just going to waste time, and it's going to make people feel like they're not doing a good enough job, like they're not a good developer, or that people are picking on them. So you don't want to do that. So again, if there's a big issue, right, let's address it. But any time nitpicking every little thing is not what you want to do in a peer review. Also, the reviewee is responsible for finding solutions to the problems found. So, you know, as the person that's reviewing the code, right? If you're highlighting an issue, your job isn't just say that's bad, that's bad, that's bad. Hey, you did that wrong. The idea is to try to highlight the solution as well. So, the way that you've done this is is an issue, right? There's a bug in it, there's a security vulnerability. I recommend that you do this, right? So rather than just saying that things are wrong, we want to be also suggesting solutions to the problem. We also try to do all of this without filling the block diagram up with comments. You don't want to leave 10,000 comments all over the place, anything and everything. Again, try to scope your peer review as much as possible to your company guidelines. If you see something that's like blaringly, maybe compliant to your guidelines, but blaringly like inefficient or whatever, just time consuming unnecessarily, maybe tag it. But again, don't just absolutely blow up every block diagram with comments that, is going to take someone hours or days to go review and look through. We also want to identify and log issues in a consistent way using an issue tracking system or block diagram bookmarks. So the bookmark manager, like I showed, is fantastic. We also want to keep peer reviews short. So short code reviews require smaller time commitments. So it's hard to bring people together. And the more people you need to bring together, the harder it gets. So keeping those short is really important. Just makes life easier. Again, if you can have a lot of these prerequisite documents already generated, it just makes everyone's lives easier because you've already got everything kind of set up, ready to go. I can quickly just glance at the reports and say, yep, it's meeting these guidelines, it's meeting these, and it just makes everything way easier for everyone else. Review effectiveness will drop off if the review is too long. So the longer it goes, it quickly stops being effective. So you want to keep them short and focused on, the code. Asynchronous code reviews also allow receivers to give feedback at a time that suits them. So it's really up to you and your organization to decide how you're going to handle code reviews, right? So, are you going to be doing them synchronously or asynchronously? It's up to you to decide, right? Sometimes synchronous is nice because you have everyone in the room together and you're all focused on this thing at the same time. But asynchronous is also really nice because, I don't have to bring all these bodies together at the same time. Other people might be busy with other things, so it allows them to review it when they get the chance. So it's kind of up to your organization to figure out what works best. Asynchronous is a great option as well. Everyone should be on both ends of this peer review process. So you don't want people that are only ever reviewing other code, and you also don't want people that are only ever the reviewee. So, you want to kind of let everyone be on both sides of that because there's not a right or wrong, and everyone needs to experience both sides. So remember, nobody's perfect. Everyone can learn from a review. Less experienced engineers will learn from having their code reviewed and from reviewing code from a more experienced engineer. So it's also an opportunity for training and learning. And one of the keys to having an open review culture is preventing an us-them mentality. So you want to kind of avoid that. Like if your team is always creating code and there's an entirely separate team that's just reviewing your code, it kind of creates that us versus them. They're trying to delay what I'm doing. They're always throwing up barriers. They're always questioning everything I'm doing. So you just want to try to avoid that us them, which if everyone acts on both sides of this process, it helps keep that straight. Also embrace feedback. Sometimes people looking at your work and suggesting that you do things differently, you can take that kind of negatively and hard. Just embrace feedback. Everyone's working towards the same goal, or at least should be working towards the same goal of just the business being successful, right? That's the dream. So we want to make sure that we're taking that feedback. As a reviewer, it is not uncommon for code you're reviewing to have some good practices for you to adopt as well. So be looking at good things that other people are doing that you can adopt yourself. and as a reviewer, point out the good areas as well as the areas for improvement. So you don't want to just highlight a bunch of things that you think should be changed, but you also want to be highlighting things that were done very well. And style guidelines. So it's really important that you define style guidelines, like I've mentioned a couple times. It gives you something to measure against. So it's really hard to check code that you don't know what you're checking it for. So I could nitpick anything and everything in that instance. So we want to have a clear scope of what things we're looking at. So NI does have a style guidelines that they've published. It's also available on the LabVIEW wiki as well if you want to take a look at it, which highlights just a whole bunch of stuff. And I think each company should basically take a look at that document and then pick the stuff that they care about and don't care about, and then either add on other stuff that you feel like is important for your business, right? So, when I've created one, like a style guideline for my own company, I looked at the LabVIEW one and I, picked out the stuff that I felt strongly about, and some of the stuff that I, didn't care as much about, I kind of left out. And then I added on some custom stuff that wasn't part of that is specific to our organization and how we operate. So that way, I was able to kind of create a policy that, isn't, you also don't want this novel of guidelines that's, a million pages. So it helps keep the focus scoped on the items we really care about. And everything else, right, that's not mission critical, we can kind of ignore, right? It can be addressed if necessary, it can be commented, but it's not a showstopper. So so that's going to be kind of recommendations on peer reviews in LabVIEW. Obviously, every company is going to do this slightly differently. This is just some general guidelines on how to do these and why they actually are really beneficial, even in that like small to medium-sized business structure. So thank you guys for watching. I hope that was helpful.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.